Factoring trinomials. Factoring x squared plus bx plus c. This is where the leading coefficient is 1. We're going to use this method. Step 1, check for a common factor. Step 2, write your two sets of parentheses. Step 3, we're going to look for the factors of our constant. That's our c term. And we're going to choose the pair of factors from step 3 that add to equal the coefficient of our middle term b. If there aren't any factors that add to our middle term's coefficient, then it's a prime polynomial, which means it cannot be factored. Looking at our first example, y squared plus 2y minus 35. The GCF is 1, so this can't break down any further. So we're going to write our two sets of parentheses. Now, to determine what signs we use, we look at the sign of our constant. Since this is a negative, in order to get a negative in multiplication, one of the factors has to be positive and the other factor negative. So what we're looking for are the factors of negative 35 that add to a positive 2. That would be a positive 7 and a minus 5. We can check our answer by using the FOIL method or distributive property. So y times y is y squared. Y times negative 5 is negative 5y. Positive 7 times y is positive 7y. Positive 7 times negative 5 is negative 35. Combining our like terms, we end up with the y squared plus 2y minus 35, which is our original polynomial. Now, order does not make a difference. So if you had y minus 5 times y plus 7, your answer would have been correct. Our next example, r squared plus 8r plus 12. Again, we look to see if anything divides into all of our terms. And the only thing that divides into all three is the value 1. So we go to our next step where we write our two groups of parentheses. Now we look at our last sign, and it's positive. In order to get a positive solution in multiplication, our signs have to be the same, either both positive or both negative. Since our middle term has a sign that's positive, that tells us that both of our signs would be positive. So we look for the factors of positive 12 that add to an 8, and that would be a 6 and a 2. And again, if you wanted to, and you should use your FOIL method to check your answer. So that gives us an r squared plus 2r plus 6r plus 12, or r squared plus 8r plus 12. Our next example, k squared minus k minus 6. Our GCF for this problem is 1, so we'll go ahead to the second step and write down our pairs of parentheses. Since the sign of our last term is a minus, one of our factors will have a negative and the other will be positive, because a negative times a positive is a negative. And so now we're looking for the factors of a negative 6 that add to a negative 1. So that would be a 3 and a 2. Using the FOIL method to check, to get k squared plus 2k minus 3k minus 6, k squared minus 1k minus 6. Our last example, m squared plus 6m plus 7. The GCF for this polynomial is 1, so we move to our second step. And we write our pair of parentheses. And since our last term has a sign that's positive, we know our signs have to be the same. And since our middle term has a sign that's positive, that means that both of these would be positive. Now we look for the factors of a positive 7 that add to a positive 6. The values of positive 7, or factors of positive 7, would be 1 times 7. And when you add those together, gives you 8. So there are no factors of positive 7 that add to a positive 6. So this would be a prime polynomial.